In microcontroller, next group of instructions are data transfer group instructions. Data transfer instructions. These instructions are used to transfer the data from source to destination without changing the content of the source. Means source contents are copied into the destination register. Source and destinations may be two registers or memory to register or register to memory. Already we are familiar with all these registers. A is the accumulator, Rn is the register, any of the register from R0 to R7 of a particular selected register bank. Hash data is nothing but data given in the instruction. If your data starts with the digits from 0 to 9, it must be prefixed with hash. If it starts with an alphabet from A to F, it must be prefixed with hash 0. Then at the rate of Ri means RAM location addressed by either R0 or R1. Direct means direct byte, means whose address is given in the instruction. Then first instruction is move A comma Rn. In these instructions, left side, after writing the opcode of the instruction, first we will write destination and on the right side we will write the source. So move A comma Rn means move the content of register Rn of selected register bank to accumulator. Next one is move A comma hash data. Move the 8-bit data given in the instruction to the accumulator. Next one is move A comma at the rate of Ri. Move the content of internal RAM location addressed by register Ri to the accumulator. Next, move A comma direct. Move the content of the RAM location whose address is given in the instruction, which is nothing but move direct byte to accumulator. Next, move Rn comma A. Now move the content of accumulator to register Rn of a selected register bank. And next one is move Rn comma hash data. Move the data 8-bit data given in the instruction to the register Rn of a selected register bank. Move Rn comma direct means move the direct byte to register Rn of selected register bank. Move direct comma at the rate of Ri means move the content of RAM location addressed by Ri to the RAM location only which is given in the instruction. Next one, move direct comma direct. In this instruction both are internal RAM locations only. So what does it mean? Move the data from source location to the destination location without changing the content of source. Next, move direct comma hash data. Move the 8-bit data given in the instruction to the RAM location given in the instruction. Next, move move at the rate of Ri comma A means move the content of accumulator to the RAM location addressed by Ri. Move at the rate of Ri comma direct. Move the direct byte content. Direct byte means the content of RAM location given in your instruction to the RAM location addressed by register Ri. Next one is move at the rate of Ri comma hash data means move the 8-bit data given in the instruction to the RAM location addressed by Ri. Move dptr comma hash data 16. Data pointer. DPTR stands for data pointer. It is a 16-bit register. So move the 16-bit data given in the instruction to the data pointer register. Next, MOVX A comma at the rate of Ri. Here what you have to remember is X stands for external memory. X stands for external memory. So MOVX A comma at the rate of Ri means move the content of RAM location. Which RAM? External. So move the content of external RAM location addressed by register Ri to the accumulator. Next, MOVX A comma at the rate of DPTR. Move the content of external memory addressed by data pointer register to accumulator. Here also X stands for external memory. So move the content of external memory which is addressed by data pointer to the accumulator register. Next, MOVX at the rate of Ri comma A. Move the content of accumulator to the external RAM location addressed by Ri. In our previous instructions also we used this one at the rate of Ri. In that cases Ri at the rate of Ri means RAM location which is on chip RAM means internal RAM locations, but in this instruction MOVX at the rate of RI comma A means move the content of accumulator to the external RAM location addressed by RI. Next, MOV at the rate of DPTR comma A, move the content of accumulator to the memory location addressed by data pointer register. Next, push direct. As we know that push and pop instructions are used for quick accessing of data from stack. So push direct means push direct byte into the stack. Next one is pop direct. Pop direct means pop the direct byte means retrieve the direct byte from the stack. XCHA comma RN, exchange the contents of accumulator and register RN of selected register bank means accumulator contents are copied into register RN contents are copied into the accumulator. Next, XCHA comma direct, exchange the contents of direct byte and accumulator content is copied into the location of direct byte and the content of given RAM location is copied into the accumulator. Next, XCHA comma at the rate of RI, right? Then exchange the contents of accumulator and content of RAM location addressed by RI means the content of RAM location addressed by RI is copied into the accumulator content is copied into the RAM location. XCHDA comma at the rate of RI means the content of RAM location addressed by RI is copied into accumulator and accumulator is copied into the register. Accumulator is copied into the memory location addressed by RI. Here only the lower order digits are exchanged. The next group of instructions are bit manipulation instructions. Till now whatever are the instructions we discussed are byte manipulation instructions. Already we know byte means a group of 8 bits means all the 8 bits can be changed at a time. Bit manipulation instructions means bit is one binary digit, either it is 0 or 1. So CLRC, C is the carry status. So CLRC means clear carry status. What does it mean? Make the carry status value 0. CLR bit. Bit means in place of bit you will be given the address of a particular bit. So clear the bit whose address is given in the instruction. SETB-C, set the SETB-C, C is carry status, set the carry status means make the value of carry status as 1. SETB bit, set the bit means make the given bit as 1. CPL-C, CPL stands for complement carry status. If your carry status is 1, it will become 0. If it is 0, it will become 1. CPL bit, complement the bit whose address is given in the instruction. Next, ANL C comma bit. This is logical operation AND. So AND the carry status with the bit whose address is given in the instruction. Next one is ANL C comma slash bit. C comma slash bit means and the carry status with the complement of the bit given in the instruction. In this instruction, carry status is ANDed with the bit given in the instruction. Here the carry status is ANDed with the complement of the bit given in the instruction. Next one, ORL C comma bit, or the carry status with the bit whose address is given in the instruction. ORL C comma slash bit means or the carry status with the complement of the bit given in the instruction. Next one is MOV C comma bit, move the bit which is given in the instruction to the position of carry status. MOV bit comma C, move the carry status to the position of the bit whose address is given in the instruction. And next one is JCREL, jump to the relative address given in the instruction if a carry is generated. JCREL, jump to the relative address if carry is generated, that is carry is equal to 1. Next one, JNCREL, jump to the relative address given in the instruction if no carry is generated. JB bit comma relative, jump to the relative address if the given bit value is 1. JNB bit comma REL, jump to the relative address if the given bit is not 1, means if the given bit is 0. JNB means bit is 0, it's not 1. JBC bit comma relative, jump to the relative address if the given bit is 1 and immediately complement that 1. JBC bit comma REL, jump to the relative address if the bit is 1 and then complement that bit also. So bit manipulation instructions are used to set or clear, means make the particular bit value as 1 or 0.